So now, let's do the same thing but with Restangular. The first thing we're going to do is to configure the base URL. All of our API is API version 1, so why do we need to write it every time if we can just set the base URL? That is what we're doing here. Then we want to fetch the user. So we have a Restangular method called one, which will create a proxy to do this get. And in here we are saying the resource name is user and its ID is 123. So by default, the main way of getting an object is /user/123, which will do the get. Then here we're calling the get method, and here we are not receiving any function success callback parameter, but because we're actually using promises. $resource has added this in the later times with $promise property, but I don't like how it's implemented. I think it should be completely promise-based. So in here, what we're doing is we're assigning the user to the scope, again, changing the name, pretty similar, and then doing the put to the correct URL. Now this is where the interesting part comes. Now we want to get the cars of that user. So we want to get a relationship from that user, which is actually a nested RESTful resource. So instead of creating the URL again, we should ask the user, hey, give me your cars, because he's the owner of those cars. So in this case, what we're doing is calling to the user the get list of cars. Restangular knows the user URL, which is /users/123, as that's the resource name and its ID. And then when we get the list of cars, it just adds /cars. This will return a promise again, and inside there, we will receive the cars. We can get again the first car, change the name, do a put. Also, if we want to these cars, we can add a new car. If we do cars.post, it will add a new car, but only to the cars of that user. So it will be a post to /users/123/cars. So this means that we can navigate our hierarchies with all and one, which are the proxy generators of Restangular. So, for example, if we want to get just a car of all the collection of users, we say all users, meaning RESTful collection of users. From there, get an element, car123, and do a get. There are some times where the name of the resource isn't actually the URL. In those cases, we can call all URL instead of all, in which the second parameter will be the URL of that resource. That URL can be either absolute, as in this example, or it can be a relative path as well. And this is basically how we can create proxy objects from Restangular. But all of this, all, one, get list, all of those methods will be added by Restangular on your promise. So on your success callback, they will be already added. So, as I was saying before, what if the element has a link to itself? In that case, we don't need to change any of our code. We just need to add a new configuration. What we are doing here is setting a new Restangular field, and we are setting here the path to get that href. So, if every entity responded by the server will have an object called self, and inside there will be a property named href with a string that will represent the URL to that element, we can use that. As you can see in the example later, we're getting the list of all the users, and then we're calling the remove on one of those users. As that user has the self href property, and it has the absolute URL, example.com/users/gonto, that will be the URL used. It also supports relative, so if your href is a relative URL, it will be taken into account with the current URL. And if an object returned by the server doesn't have this property, then it will fall back to the default Restangular behavior, which is using the ID of the element and the name of the resource. So, another thing that is important is, once I receive a user, a car, or whatever, I want to be able to add new methods, new properties to those entities, because we want to interact with it and we want to give it behavior. So, for that, Restangular has two hooks. It's add element transformer or extend model, which is actually a shortcut. Add element transformer, in there, we just say, hey, whenever you receive a resource of the type users call this callback function. The second parameter, which is a false, means I just want to modify elements. If you set it to true, it means I just want to modify collections of users instead of just one user. And if you just don't put anything, it will be called for everything. And in there, you will receive a user, and it's a regular JavaScript objects as all models in AngularJS, so you can add the property you want, a function or whatever. But Restangular has also a helper function, which is called add Restangular method, which will add a new method to that entity that will do an HTTP request the way you want. In this example, we're saying, hey, add a new method called ping, which will actually do a post to the do ping path, and do it with the headers x-app example. So later in the example, you will see that we're doing users sub0.ping. That will actually do the query that we have said before. If we had put there user.name equals Gonto, we could then ask a user, which is the username, and it would return Gonto. As you can see, it is after you have configured it, you don't know that it's been added, it's transparent to you, because you will receive in the promise a list of users, and every element of that list of users will have this extra method that you have defined in the configuration. So, what other configurations does Restangular have? Restangular actually has like 20 or 25 configurations. You can see them all in the GitHub page, but some examples of it are first, what if your ID of every element isn't the ID field, which is like the most common? You can set the path to the ID. For example, if you're using Mongo Labs, your ID will look something like this with underscore ID, and you can use it anyway. Also, you can set request interceptor so that it will be called before every request. Response interceptor, which will be called after every response, and error interceptor. With that, you could create, for example, a global loading. So before every request, you start the loading, and then if there's a response or an error, you stop the loading. Those are just examples. You can see all of them in Restangular's GitHub page. Another thing that I was telling you about is that we can create scoped configurations. What does this mean? That with Restangular, we can actually build a new Restangular service with some configurations that we want. So let's assume that our common Restangular doesn't add any header, but we want our bond Restangular to always add a header, which is xout James Bond. In that case, we call the with_config method. That method will receive a configurer by a parameter, and that configurer will have all the same configurations as the Restangular provider, so there you will be able to configure anything. That will return a new Restangular object that then you can use to query anything, and all those configurations that you have created will be used. Most of the time, this feature is used with custom services in AngularJS. So, for example, a lot of people create a comments service, which will be used for comments resources, and in there they add the headers that they are needed, the request params, and all of those will be used for that comments resource, for example, and all its nested resources. Well, another important thing is that it uses ETAG by default. So if your web server supports ETAG, we will be sending the if not match, the last modified, and we will be using it. If your server doesn't support ETAG, you just don't care about this slide. It's entirely based on promises. So it's really promise-based, which is the way that it should be used. It supports all HTTP methods. It means it has options, it has headers, it has patch. Currently, it's every time more important to use patch, because with real-time applications, we want to send changes. Restangular supports that by default, and other resource doesn't. Also, you can run your custom operations. So, if you want to do a put or a post to not like a regular URL for putting, if you want to do a put instead of to the elements to another path, you can do it by calling custom put, custom post, and in there you can just customize the object, the request parameters, the headers, or whatever you want, and more stuff. You can check it out at github.com/engonto/Restangular. Engonto is also my Twitter handle if you want to add me. So this was the presentation to learn about Restangular. Thank you for listening, or at least pretending to. It says questions, but the questions will be after Jeff Cross' presentation, so this slide doesn't exist. Thank you, everybody.
Thank you for this presentation. It's a very interesting take on how to do RESTful URLs. I like it. There's a lot for us to a lot of cool ideas in there that I really enjoyed. So now, Jeff is going to present another way of talking to the server, which is Realtime API. Thank you, Mr.
Hello, I'm Jeff. Can you hear me okay? Yeah. Okay. I work on the Angular team at Google. I am presenting on something called OmniBinder at the moment, but this name has changed quite a few times, and it will probably change again. And so when Martin wanted to present tonight, I thought it would be a good opportunity to talk a little bit about this new framework I've been working on top of Angular and the problem it's solving. So the high-level goal is to be able to bind Angular models to anything. Particularly anything outside of the Angular app itself. So why a new framework? Remote data binding should be as easy as in-memory data binding when working with an Angular application. It's not easy to do this with, it's easy to do this in an app where you just have local data that's in memory or even in client-side storage where you're the only user using it at the time that you're using an app. It's not as easy when you have distributed data that is being used by multiple people, changed by multiple people, in different client applications at the same time. There should be a first-class API which services third-party APIs and others could implement and work with in Angular that makes it easier for them to make bindings. So, like Firebase, they've made their Angular file library, and they had to do a lot of work to make that work. But they've actually been helping on developing this new framework that does a lot of the heavy lifting of the hard things inside of Angular. An app developer should only have to know one library that binds these various protocols. So I shouldn't have to learn, if I wanted to integrate with the Google API, for example, I shouldn't have to learn their Angular framework that they've developed from scratch to know how I need to prepare my models for it. I just want to understand in one place how I can bind to different protocols and then drop in their protocol underneath to be able to persist and update my data. So what is OmniBinder? It's a real-time micro framework on top of Angular. It makes it simple to bind Angular models to any supported backend. And it automatically synchronizes data between client and data store. So typically the data store will be some external data service, but it does not preclude local storage or other types of client-based storage. And it's a collaborative effort with members from Angular, Firebase, Strongloop, and some other teams. So I want to show a little bit of a demo of the working version of it now, and then talk a little bit more about what's happening underneath. So I'm using Deployed, which is a framework that myself and Richie Martori over there worked on, and it makes it easy to build APIs. And so I have an API that's powering this that has a collection of to-dos. And in this application, I just want to create to-dos, check them off, and get rid of them. So I'm going to open the same Angular app side by side. And then you see if I create a to-do here, it creates it on the other screen. And if I create one here, it also goes to the other side. And these are ordered alphabetically. So if I check one off here, it also checks off on the other side, and the same if I uncheck it. And if I check this and then archive it, it will delete this and delete it in both views. So all this was accomplished with just a little bit of code using the OmniBinder framework. So here is where the magic part is, and I'll show you a little bit of a closer view of this in my presentation. So in my controller, I had a deployed protocol ready to go, and the protocol is something that works underneath the OmniBinder library to handle the low-level data synchronization to a service. But in my controller, all I had to do was create a binder instance using an OB binder factory, which takes a scope, a model name, a protocol, and some options. So here I have an option which is key ID, which says inside of my collection, the unique key is called ID. So OmniBinder uses this to ensure some operations are safe, that it's updating the right object rather than relying on position within a collection. And this type says what type of model it is. So I can be explicit about this should be a collection. And this query is something that my protocol asks for. And here, the deployed protocol just wants to know what the collection is called, so it can perform all the operations after this. And here's a diagram of how it's actually working without showing all the parts that are making it work. I have changes that come from my scope and my model, my model on my scope, and those go to the binder, which then kicks off a change pipeline, during which I, as a developer, can intercept changes before they go to the protocol. And then the deploy protocol handles the business underneath that applies the changes to my database. And the process kicks off the other direction when I have a change inside of deployed. It goes to the binder, which then kicks off a change pipeline to the scope, where the changes are applied to my local model. So what are the goals of OmniBinder? So the goal is to provide a contract between protocols and Angular models. And I'll show a little bit about what that contract looks like in a moment, but also to solve common problems associated with syncing, like recursive updating. If you've built a real-time framework with Angular or anything, you know that if you just try to bind something without intercepting changes from a model to a protocol, you're probably going to get an update from the protocol after you've just updated something saying, okay, you've created this resource. Oh, here's a new resource that was created. And then you have to determine, was this the same resource I just created, or is this some other resource that my protocol is giving me? And then you apply that to your model, and your model will fire off a change and say, oh, something's changed here. We try to remove that problem inside the framework so you don't have to think about it. Representing subsets of large collections of remote data. So working with 1 million rows of data on a remote database without having to load 1 million rows into memory, which doesn't work very well. That's a problem. We want to make it as seamless as possible to act as if you're manipulating the entire collection locally. Throttling and batching updates, so conserving network activity. If you're making if you're binding to a key up event on a model, for example, you may not want to send every event to the protocol. You may want to wait for 250 milliseconds or so to send all those changes at once, so you can be sure you're not overwhelming your network. So what is it doing to accomplish these goals? So one, we've implemented object observe style change sets in the pipeline. So if you're not familiar with object observe, browsers are starting to implement these APIs. They're working out a standard on how to watch changes on objects and arrays and respond to those updates, which is driven very much by how Angular works, because we have the ability to watch objects and respond to those changes. But now there's native functionality that's rolling out in browsers that when an object changes, you can see what type of change it was, where the change occurred, and what the old value was, so you can do something with it. So in OmniBinder, we subscribe to this, and we say when a model is updated, we want to package that change to the model in an object observe or array.observe fashion, and send that to the protocol in the same way, so that it can just persist that looking at this change. Second is that we're implementing a simple contract for protocols to implement. There are really just two methods a protocol needs to provide. So I can create a service for my protocol in Angular, and I just have this process changes and a subscribe method. And process changes looks at changes on this delta object, which are those object observe or array observe changes, and then determines how to apply those to my collection on the database or wherever it's being stored. And then there's a subscribe method that says, take my binder, look at my query, and then figure out how to subscribe to changes on the server and notify me when things change. So under the covers, there are some other things going on. There's an OP Observer service that uses object observe and array.observe to watch arrays and their child objects. Again, as a developer, you don't need to see this, but this is something that's doing the heavy lifting. And OB-binder observes both directions to syndicate changes to the model or protocol. And it treats both directions pretty similarly. And model writer is a service that is the equivalent of a protocol, which applies changes from a protocol to a local model. So the third or fourth thing here is this change pipeline. And so this is a concept that you can implement a protocol that is on the other side of a model that can accept changes that come to it. And if you want to, you can just let the binder do all this work for you and say, just figure out the changes, give it to the protocol, and let the protocol persist it however it wants to. But there are cases where you want to apply some other behavior or process changes before they get to the protocol. And so there's this change pipeline concept, which I've implemented and reworking now, but essentially how it works is when a change comes from the model, the OB binder registers that change and kicks off a change pipeline to the protocol. And in that pipeline, I can implement a series of middlewares with a signature like the one I have here, binder delta next, where I can do whatever I want to look at the delta. I can stop the delta or wait for a while to continue processing it. I could add a unique change ID to this delta so I can store that for analyzing later. Or I could do whatever I want, and then it eventually gets sent to the protocol. So a protocol could say they don't want change, you use a change pipeline, but you have the ability to use it as a developer. And another example is you may want to batch changes, like I mentioned earlier, from a protocol or from a model so that you can package them together instead of applying everything one by one. And this is better documented on the GitHub project, which is linked to in the slides, and I'll share another link at the end. So the current state, it's a working prototype. I'm starting to spend more time on it, and I've been working with some other folks on making it good. But it is a prototype right now. I wouldn't throw it in a production app just yet. And the focus right now has been binding arrays of objects, which I think is the most common use case for data in applications. It requires object observe enabled, but this will be polyfilled. So you'll have to enable this in your flags in Chrome, enable experimental JavaScript to see this work. The design doc is on GitHub in the README. There are some goals for the project and problems it's trying to solve. And what's next? So we're starting to use it with some real-world applications and see what are some things missing from it, particularly the design. What are some flaws of the design? What does it not let you do, or what does it make difficult? And what could be done to make it easier? The change pipeline implementation is being re-implemented. More protocols supported. So Firebase is one of the initial protocols. We're working on the Angular Fire library to work underneath this and also deploy it, but I'm interested in adding more API services and data services underneath it. Supporting more types of data, so rather than just arrays. And implementing Object Observe more deeply in Angular, which is an ongoing effort to start to replace some of the work that we're doing with Watch right now. We're starting to use Object Observe to do that instead. And last is standardizing protocol for real-time web apps. So this is another collaborative effort. There's a good document on the GitHub project with some thoughts from myself and a few others involved with this called Stretch Protocol that I'd recommend taking a look at. But most of all, I could use help. If you like to live dangerously, I would say grab the project, create a protocol, play with it, read the docs and see what you think about the design approaches, and submit issues or pull requests on the GitHub project. And I'd love to hear what you think. So thank you, and this is the URL to the project. Do we have microphones?
Thank you, Larry. When you get update messages,
We have to do it for the live stream.
repeat the question. When you get update information from your database, is it relevant to records you have checked out or to the database as a whole? How do you focus update messages so that you're not receiving a fire hose from everything happening in your database?
So that's up to the protocol to implement that.
On the client side or the server?
On the client side. and the server needs to know how to interpret it. But the place you would specify that when creating the binder is in the query object. So that's the kind of arbitrary object that the protocol says, if you want to bind to me, here's how the query should look. And you can say page 1, this many records, matching this query inside of it.
So it seems like you guys are already working on a RESTful resource protocol of some sort. Is that, because that's the pain. Two people looking at the same website don't get an update for a RESTful object in the other browser. So is that described on the GitHub?
Yes, it's in a document called Stretch Protocol on the GitHub project. So if you go to this and look at the README, there's a link to it. And others are doing some interesting work in this too. So we're just trying to get something that's adopted by several people, several implementers. And so Firebase is helping with this, and so they may add some ways of supporting a new type of protocol directly, but I can't speak to that.
I had a question pertaining to the earlier talk about Restangular. For the API to get collections, is there any support for backend services that don't implement, like have paginated responses, so you can't get the entire collection all at once?
Yes. Right now, you can use the response interceptor, which is a configuration for the Restangular provider, and in there you can create your own object. You need to return there the array of the results, but you can add properties to that array as it's JavaScript, and you can add metadata there. There's a question in the FAQ regarding that, and you will see the example. But basically, what you would do is create a new response that will return the array. You then there add a metadata property, which will have the paging information, and you can add then two Restangular methods, which will be next and previous, and they will use the page information to do the new GET request. So with that, you can configure a paging style with arrays and with Restangular.
Thanks.
No problem.
I had a quick question. Sorry, I got lost a little bit. Do you need Firebase to make the real-time updates happen?
So no, you don't if you have your own protocol, but there are no protocols written underneath it right now. So
Firebase is only what you would have to have Firebase running to be able to use it today.
today, yes. So it's a very early framework.
Right. Because of some server restrictions, we have all our API calls as a post method, not get method. How we can leverage Restangular in that case?
I didn't understand. Could you please repeat?
We don't have a get method, HTTP get method for all our API calls, but just post. How we can leverage Restangular in that case? I mean, what are the restrictions if there are?
Okay. If you just have post in your API, you can use it anyway. What you would do is you would use Restangular's proxy only. So, for example, if you want to post to certain URL, which is like user/123/cars, you will do Restangular.1 user123.all_cars.post, and inside there you just send the object, and it would work.
Can you send multiple GET requests to a resource using Restangular?
Multiple GET requests
Yeah,
to what?
like multiple requests to the same resource.
Yes. Once you have one resource created either with the proxy or you have some answer from the server, you can do, like, for example, $scope.user.get, and that will actually return a promise, and you add the then. But in the future, you can do again $scope.user.get, and that will return a new promise with a new get. So you can do whatever you want.
Okay, so what I'm trying to understand is, does it send a single get, or would it send two to the server?
It depends on the browser right now. For example, Chrome, when you do like 3 gets almost instantaneously, it knows that you're doing 3, so it's just going to do 1 and return a cached response for the other 2. I think Firefox is implementing that as well, but if you use IE, of course that doesn't happen. No problem.
So a question about OmniBinder. If we use OmniBinder, does it offer any advantages to using Angular Fire as it stands today? I mean, Angular Fire as it exists right now.
Not today. So I know with Angular Fire, I think they had a lot in their roadmap. I think they were probably 25% where they wanted to take it, and the complexity of building it kind of slowed down them from going further with it. And we're working on making Angular Binder work with this. So today, if you were doing it, I would say keep using Angular Fire because this is so early and so subject to change. Down the road, I think Angular Fire will be more implemented with this. And so the other advantage is if you're wanting to support other APIs or use other services in your application, then you're using one interface to bind to all these services inside your application rather than having Angular Fire used the way it is now in some places and then having some other construct for binding to other services and APIs.
I have a question over here regarding Restangular.
Sorry.
So when it comes to like, you're making a cross-domain call to a REST resource, it's been a pain in the past, just using vanilla jQuery or some of these other libraries. How did Restangular make that easier if it does at all? Do you still have to tell it to use a certain different method to access that cross-domain?
When you're using cross-domain, actually Restangular uses $HTTP below, so it will be the same as using $HTTP. What you will do is set the base URL to the other URL from the other place that you're doing, and it's the same as $HTTP. It will do first the options. If it returns that it's okay, then it will do the get. But that's actually done by $HTTP. I don't do anything about that.
Okay, thank you.
No problem.
Cool. I happen to work for Move.com, and anyone's looking for a job, we're looking for Angular developers. Come see us after the session.
One more question about Restangular. I'll piggyback on the question on paging. If you work with the grid, usually most of the grids have the pagination and sorting and filtering as the standard features. Do you have any plans to include it, to extend Restangular to support it, or you have to write custom code every time you use a grid?
Right now, you have to use custom code, but that's basically because there's no standard way of doing paging right now. So what you would do anyway, you would write custom code, but it's like 10 lines only, because you would add the metadata, and adding the next function is just the line of declaring that, the line of add Restangular method, which will use the paging information, and then the closing bracket. So it's 10 lines. It's not that much.
She's bringing him up.
My question is, what's the trigger, the update for the server? Just you issue the two windows, right?
I'm sorry, what's the, is it for me or for him?
I don't understand either.
For you, yes.
For me or for him?
For both.
Oh,
I mean,
okay.
So my question is, what's the trigger, the update from server side?
So yeah.
Just you issue the two window, right? So that's two-way bonding. So I change the left side and the right side will sync up, right? So I don't know what's the, how to say, the change event. The client can listen to the event and get a response for the server.
So so how it works now is Binder has, so the Binder instance has a method called onProtocolChange that you call with the object observe or array observe style changes as the only argument. So it's up to you when you implement the protocol to figure out how do I know when the service changed, because every service is different. You could just so you might say that if I'm polling or something, then I would Every time I pull if something's different, then I would kick off the change to binary.on protocol change. Otherwise, you might be listening on WebSockets, and it might emit an event that says, oh, this is updated, and at that point, you would then call binary.on protocol change, and would give it a nicely packaged change set to process. So it's up to the protocol to kick it off.
Okay, thanks.
Looks like one more question.
Gentleman in the blue shirt. I was pointing at you, Michigan.
But I think one more question over here. And then I think we will wrap it up, and afterwards, if somebody wants to make any announcements, and take those.
Simple question. Do either of you have your slides online somewhere where we can get to them?
I will post mine.
Mine are on GitHub already, but they will be posted on the meetup, I guess, soon.
Okay, thank you.
One more question. Last one.
Yeah, about maybe 6 months ago, there's only AngularJS. Now there are a lot going on around there, like omni-binding, AngularFire, Restangular. I'm kind of curious about, the roadmap of Angular. Are you going to merge them into AngularJS library at some point, or are you gonna just keep them as separate libraries?
For both of us, or for?
In general, maybe yours.
So Angular in general is becoming more modular, to where things are in separate modules. So I don't think this will ever be in a tightly coupled part of Angular. So it'll probably always be its own module.
Your omni-binding makes sense to merge omni-binding into. Oh, sorry. Okay. I think omni-binding kind of makes sense to merge into Angular framework.
Yeah. So it'll probably be when it's more mature, like part of the collection of first-class modules of Angular. But a lot of folks won't need it, and so one of the motivations for splitting Angular into separate modules is that if people, like for example, resources its own module because people like Restangular, so they don't need those bytes downloaded with every person opening their app. So same with OmniBinder. If people don't need this feature, then it's off.
Yeah, makes sense.
Thank you guys for presenting. We'll take a little bit of a break. If somebody wants to make announcements about some awesome job we have, something like that.
Hey, Christina, are we off the director? The video results?